All right. So now that we've got the basics of Python and we're familiar using the different interfaces, whether it be the command line or using a scripting window or using the Jupyter notebooks, I want us to get started in some of the more advanced features, or actually not advanced, introductory at this point. So first we're going to talk about functions. It's really important, obviously. In math we use functions all the time. So if we say f of x is x squared, then what's f of 3, f of 5? We know how to evaluate that. So in Python we can do a very similar thing, much like what we did in R, I will mention. So we first define the function. So def f of x colon return, and then we tell it what to return. So the syntax is, it's different than in R, but the structure is identical, more or less. It's just we have to modify how we think about the syntax. That's all. So if we run this function and then we call f of 3, what does it do? Make a prediction, and then actually let's type this out and test it. I know it seems kind of silly, but remember I told you on the first day of class, I really like that book, Learning Python the Hard Way. And if I follow that author's instruction, this is exactly what we should do. We are learning functions for the first time, so we're going to actually type out a very simple function that we already know what's going to happen, and we're going to make it work. So take a moment. I'm going to pause and type it out just so you can see too. You don't need to see me type. But then make sure you get my result that you're going to see in just a moment. So notice I typed out the function just exactly as it appears in the notes. Then I evaluated the function at x equals 3, and we get, of course, 9. As we all could have predicted that, but just I think going through this, quote, the hard way at first takes, 20 seconds, but it's well worth going through and doing this in a very well thought out way. Okay, so back to the notes. So a few key features for defining a function. Def is a keyword. It has special meaning, so you can't use it. So if you're wanting to define a definite integral, you can't call it def, for example. You're going to need to think of a new name. The return statement terminates your function. So this is kind of like the end of the brackets. And you are telling Python here, not R, you're telling Python here that it's the end of the function, basically, and to determine that value returned by the caller. If there is no return, the function terminates when it reaches the bottom and returns nothing. Notice how the body of the Python function is indented. This is actually a requirement and should happen automatically, like when you're scripting in a Jupyter notebook. You may have noticed that, in fact. X is your parameter, okay? Remember that from math, really important. X is a variable accessible only from within your function. So if you have a big, long function, we're going to learn later how to debug. But X doesn't have a value outside of that function, okay? It's local in that function. We can use any name we want. We could use Bob for the name of our parameter, and we'd write a function, definition f of Bob, return Bob, exponent 2. It doesn't matter. Which of the following contains a function call? So we have options here, or examples here, 1 up to 4. So take a look and take a moment just to think and make sure you know which includes a function call. Okay, so hopefully you've had a moment to think. You may be wondering, what exactly is a function call? Maybe you need to compare and contrast that to a function definition or defining a function within Python. So notice 2 is defining a function. So that's distinct from, different from a function call. Whereas 1, where we inquire about the type, which, 4.5 is going to be floating point, but where we inquire about the type, that is actually a function call because we are making use of a function that's programmed within Python called type. Similar for area, similar for print. These 1, 3, and 4 are all function calls. 2 is what? You should, if you need to pause and go look, that's okay. But 2 is exactly what we would call a function definition. It's adding your own user-defined function. So that's a very particular thing, adding one in. Not something that would be programmed within Python, but you can add it as a new function. Then you can call add_1 as using a function call, like add_1 with parentheses 3 would be a function call. All right, so make sure you've got that straight. Know the difference. There we go. Let's do another concept test. What's the output of this code? Take a moment to evaluate and think. And this one we're going to actually, I want you to bring an answer to class. I think you'll have that along with your other concept tests that we can discuss in class. Take a moment and think. Okay, so make sure you are certain and have a good reason for why you believe your answer is your answer here, and we'll discuss it. Okay, so notice here we have the return value is a plus b plus 3. What if we change that? What would we have then? Oh, and notice also the call itself has, the function call itself has also changed. So we'll discuss these in class. What are the bugs? So a big part of writing writing functions, defining a function, is understanding how to debug. All right, so let's say we define this function add1. Then we make an assignment statement, so x is 2. Then we make a self-referential statement for x, and then add 1x. So obviously, well, I shouldn't say obviously and give you any answers. I'm really trying hard not to do that. Take a moment, think about this. You can even go to your Jupyter window and try this out. See what you get. In fact, I would recommend that. I would just do that even if you're certain about what's going to happen here. I want you to think about, though, before you do it, make a prediction and think, what could be wrong here? Are there any bugs? And what could fix it? As you type, you might find something. It's possible. I'm not saying you will, but it's possible. Okay, so just take a moment. I'm going to pause and do the same thing. I'm going to go through all of this with you and make sure I hit all the fine points I should. Okay, so notice I typed it within the Jupyter notebook. First of all, notice when I made the function definition, there's an automatic indentation for the programming statements within my function definition. And that did not, let me switch back real quick, but if you go back to the notes, actually, it's kind of difficult for me to switch. But if you go back to the notes, notice that that was a syntactical error in the code that you would have needed to have addressed. But I've gone ahead and fixed it here. Then I made the assignment statement x equal 2. Then I made the new assignment statement making use of our newly defined function add1. Then I printed out the result. And I think this should make sense to you and make sure you understand exactly what's going on programmatically here. You may have thought initially A, and that would have been reasonable if you didn't remember you needed to indent in the body of the function. So actually B. By the way, take a look at C. We are using x as a parameter and a variable, but we're not allowed to do that. Actually, go back and read the notes about that. Both B and C are bugs. No, just B. Okay, so let's think a little bit about making a recipe I happen to like recipes, but it's a really good idea when you start scripting in a new language. We're going to use some recipes for writing functions. This is taken directly from programming. Oh gosh, it's a Python book. I'll make sure I show you this in class. Programming Python like a computer scientist. I think I'm saying that title wrong, but I'll show it to you in class. But this is their recommendation from that book. We're going to think of this as a set of steps here. So step 1 is write some examples of your function call. So if you want to say glue two separated character strings together, you could write a function glue underscore strings and combine, say, a first name and a last name and make it a full name. Step 2, write the type contract. What we mean by that is what kind of value are you going to accept and what are you going to return? So here we have two things that are arguments in our function glue underscore strings. Notice they are both character strings. Okay, both of them, John and Smith. And then what's the output? A new character string. So we're taking two character strings and making one. Then it's important to have a well-defined header. So I like how you set it up like this, right? So you say first your keyword def, then the name of your function. Make it informative. And nothing irritates me more than calling things function 1, function 2, function 3. The only time I do that is when I'm running a bunch of models that I might call it RF mod 1, RF mod 2, saying here's my first random forest model of type 1, and then I do something to tweak it and call it a second version. But let's use informative names like glue strings is an excellent example. String 1, string 2, even those are somewhat informative. Add a description of the function. This is really good when you have something complicated. Here we could read the function and know exactly what's going on, of course, but when it's complicated, write a description such as return the string composed of S1, a space, and S2. Then put it all together. Step 5. So we're going to practice that in class in our lab, but make sure that you think about each of those 5 steps as you go about writing your first user-defined functions in Python. Okay, so there's also this concept of modules in Python, not the modules I use online, different. Modules are a way that we can group functions within Python and use import to make all of that grouped set of functions available to an end user. Okay, so anytime we have a file ending in .py, that extension, it can be a module. It's a really important concept here. Import runs all that code in your module, but only the first time. If you make changes and then try to import it again, it's not going to work for you. Okay, it's important. Only that first time. If we import some module underscore name, we access its functions using that name. So notice if I have a function called function underscore name within my module called module underscore name, I make reference to that function by using the syntax module name dot function name. Really important. You'll see this happening all the time. There's going to be some kind of nuances that we add to this in just a moment as well to make, sometimes module names are really not convenient, and we can do things to make them more convenient. Okay? To access the function name without having to type that prefix of the module name, we can use the following script. From module name import function name. Then if you know you're going to call that function name 20 times in your script and you don't always want to write module name dot function name, then you can use this as an alternative. It makes it more permanently available. Okay, so that completes our introduction to functions. We're going to continue on with data types after this. See you in a bit.